And we are back. The 2024 AP Calculus AB free response question number 5. No calculator. Fizzler sticks. We'll be fine. We'll be fine. We'll all be fine. Let's just take a deep breath. Let's go get this. Let's go get this problem and show it who's boss. Number 5 reads, consider the curve defined by the equation x squared plus 3y plus 2y squared equals 48. It can be shown that dy dx equals negative 2x over 3y, negative 2x over 3 plus 4y. 5a states, there is a point on the curve near 2, 4 with the x-coordinate 3. That seems pretty important. Use the line tangent to the curve at 2, 4 to approximate the y-coordinate of this point. All right, use the line tangent to the curve. That tells me y minus y1 equals m times x minus x1. We are going to use this, plug in an x value of 3 to approximate what the y value will be, or the output, in this function. First off, let's state the obvious, okay? My x is 2, my y is 4. So my x is, I clicked the green one, kids. The x is going to be 2, and the y is going to be 4. So let's just take care of that right now. We've got y minus, my y value is 4, equals, I don't know the slope yet. We have x minus my x value, which is 2. There you go. All right. Now, I don't have the slope. My slope is just dy dx, which is negative 2x over 3 plus 4y. Now, yet again, let's not forget, my x is going to be 2, and my y is going to be 4. So let's go ahead and plug those in. We have negative 2 times my x, which is 2. It's my x, and here's my y, over 3 plus 4 times whatever my y is. Okay, it happens to be 4. Negative 4 over, that's 16 plus 3, 19. That's my slope. It's not this nice, neat whole number, but who cares? All right. Now, if they wanted just the equation of the line tangent, fine, just like that. But they want to know, when I put an x value of 3 in there, what's my y going to be? So for the sake of ease, I'm just going to add 4 to both sides. So I now have y alone. And why not? Let's distribute this. No, we're not going to do that yet. We have negative 4 over 19. My x is 3 minus 2, because my x is 3. And we still have a plus 4 that we brought over to this side. All right? So negative 4 over 19, this becomes times 1 plus 4, which is just negative 4 over 19 plus 4. Oh, they can't make it easy for us, right? How do I represent the number 4 with a 19 in the bottom? Okay, 4 times 9 is 36. Carry the 3, is that 76? Interesting. And if I take 76 and subtract 4, that's 72 over 19. And that would be my y value using the equation of the line tangent. Okay? That would give me my y value when I plug in an x value of 3. Okay, 5b. I could see how there will be a lot of questions here. Okay, and let's just read this, and I'm going to explain my rationale behind how I solved it. And I'm sure maybe someone solves it a different way, but I like to think mine is simple enough once you visualize it. 5b reads, is the horizontal line y equals 1, tangent to this curve. Give a reason for your answer. First of all, let's visualize this. Okay, here's my y-axis. Here's my x-axis. Here's where y is 1. Here's the line y equals 1 right here. Okay? Now, in order for that to be a line tangent, remember, if I have a curve, a line tangent touches it at one spot. That's it. It doesn't go through it and touch it at multiple spots, okay? Just at one spot. So in order for y, okay, equals 1, this line right here, to be a tangent, it would have to touch at a max point, or whatever, maybe it would have to touch at a min point, okay? It would have to be the y, this y value of 1 would have to be the y coordinate, either here or here, of the critical value. All right, does that make sense? In order for that green line to be tangent, it either has to touch the max point or touch the min point. If that's the case, this point right here or this point right here would have an x value and the y value would be 1. Okay, whatever the x value is, the y value would be 1 here. Maybe this is 2, so it would be 2, 1. Okay, maybe this is 7, so this would be 7, 1. All right, so that's how I'm going to tackle this. Right, I want to see if I have a critical point that has a y value equal to 1. If I do, then I have a tangent line that can be y equals 1. So, first off, let's find and see if we have a critical point. That means my first derivative has to equal 0. Negative 2x over 3 plus 4y. Where does that equal 0? First of all, in order for any fraction to be 0, my numerator has to be 0. Okay, so let's just continue that point. So this is just basically saying, where does negative 2x equal 0? Well, if I divide both sides by negative 2, that happens when x is 0. Okay, so I have a critical point at x equals 0. So right now, okay, if I just come here and I, let's see if I can get all this stuff out of the way. Move all this stuff out of, I have a critical point where x is 0, so I'm going to move that right there. That means my graph would either have to have a max there or a min there. Let's do this in a different color. It would either have to have a max there or it would have to have a minimum there. Okay, and that would have to be at the point when x is 0, y is 1. Okay? That's the only way I can have a tangent line. All right, so I mean, I guess what I'm doing now is overkill. I really don't have to do this. But I'm going to do this first and foremost. How come? So when x is, we'll say dy dx is 0. First of all, I want to see if it's a min or max there. Okay, so I'm going to try negative 1 and positive 1. Okay, into, all right, into my derivative. Now remember, this can only happen when y is 1. So when I look at my derivative here, my y value, I'm going to put in a 1. What happens when I get 4 times 1? That's 4 plus 3. The bottom is going to be 7. So my derivative, the bottom is 7 and the top is negative 2x. All right? Because remember, it has to happen where y is 1. So really, I'm just going to throw my x in here. If I throw a negative 1 in for this x, negative 1 times negative 2 is positive. That means right here, I have a positive slope. What happens if I throw in a 1 for my x? Well, negative 2 times 1 is negative. Okay. So I do. That critical point is a max at 0. So if I go here I have a max at 0. The question is, that doesn't mean I have a horizontal tangent line. That just means, okay, that just means that's where my max is. I don't know if it's at y is 1. Maybe it's here. X is 0. Maybe it's down here at the origin, 0, 0. So what I got to do now is I'm going to find, if I throw 0 into my original equation, okay, if I throw 0 into my original equation, what's the actual coordinate of this? I know that x is 0, but what's the y? Is it 1? If it's 1, then yeah, I have a tangent line, because that's what it's asking me about. But if it's not 1, okay, if it's not 1, then yes, my max is at x equals 0, but it's not where y is 1. And I wouldn't have a tangent line there. So how do I do that? I got to go back to my original equation. And you might be thinking to yourself, goodness gracious, if I throw a 0 in for this x, okay, if I throw a 0 in for this x, this goes bye-bye, how am I going to solve for this y? I've got an easier way to do it, kids. Trust me on this one. I'm going to take this whole equation, and I'm going to see if it works for 0, 1. So my x is 0. So I've got 0 squared plus 3, this is my x, times my y. We're going to put in a 1 for y, plus 2 times y, which is 1 squared. Does it equal 48? Oh, thanks. Okay, does it equal 48? Well, 0 plus 3 plus 2 does not equal 48. 5 does not equal 48. So I do have a max point at 0. But it's not when y is 1. That doesn't work. That's not a coordinate. They're not asking me to figure out what y value it is. Just, do I have a tangent line there? So the answer is no. Y equals 1 is not a tangent line. Okay, give a reason. Well, we gave a reason. Do I got to remember a reason? My reason is this right here. That's right here. And this right here. Okay? I did the work. It didn't say explain. All right? And my reason is I have a max point, but it's not at 0, 1. 5C. The curve intersects the positive x-axis at the point radical 48, 0. All right, this seems like it's pretty important, but we'll come back to that. We got bad there. Is the line tangent to the curve at this point vertical? Give a reason for your answer. First of all, if I have a vertical tangent line, that means my slope would be undefined. Okay? So, at this point, they're saying, so let's take my derivative, negative 2x over 3 plus 4y. All right? And see if that's going to be undefined at the point radical 48, 0. When x is radical 48 and y is 0. Let's do this. My x is going to go in here, and my y is going to go right there. Negative 2 times the square root of 48 over 3 plus 4 times 0. That's negative 2 radical 48, which is fine. I don't got to simplify that, over 3. That is not undefined. Okay, that's not undefined. Give a reason for your answer. So let's answer the question. No, not a vertical tangent line at radical 48, 0. since my derivative does not or is not undefined at that point. There you go. That was a pretty simple one. I mean, B was a little bit more in the explanation category, right? But C wasn't that difficult at all. All right, on to the last one, 5D. For time t is greater than or equal to 0, a particle is moving along another curve defined by the equation y cubed plus 2xy equals 24. At the instant, oh, I'm going to like this, at the instant the particle is at the point 4, 2, the y-coordinate of the particle's position is decreasing at a rate of 2 units per second. At the instant, at that instant, specific instant, what is the rate of change of the x-coordinate? Oh, man. So related rates, okay? So dx dt is what we're solving for. They give us dy dt. That's negative 2. It's negative because it's decreasing at 2. And they give us an x is 4 and a y is 2. Okay? So, in the review video I did, I mentioned related rates. I briefly described how they would work. We did not have a problem in the review video to do like that, but I did mention them, and I love these types of problems. So, what I've got to do now is take this equation and take the derivative of it, but I'm not just doing it implicitly where I put dy dx or dy dt next to my y. Since it's a related rates problem, we got to put dy dt next to every derivative for y, and we also got to put dx dt next to every derivative that we take the x term. All right, let's go. We'll go blue. Okay, the derivative of y cubed is 3y squared, but that's the derivative of y. So I put dy dt next to it, okay? Plus, now I have product rule. I'm going to consider, I don't know what happened there, kids. I couldn't speak for a second. I'm going to consider 2x my first term and y my second term. So what is the first term? 2x times the derivative of y, which is 1. But since it's the derivative of y, we got to put dy dt next to it. Okay, first times the derivative of the second, plus the second, which is just y, times the derivative of the first. The derivative of my 2x is just 2, but since we're taking the derivative of an x term, it's dx dt. Okay, equals the derivative of 24, that's a constant, is 0. Yes, you need to take the derivative of the constant at the end. Now, let's start plugging things in. My x is 4. Boop, right there. My y is 2, right there, and right there. My dy dt is negative 2, right there, and right there. And we're trying to solve for this, okay? So I'm not going to have everything. That's the question mark. I'm not going to have my dx dt. That's what I'm solving for. So let's plug everything in, and it's going to end up being nice and easy. 3 times my y value, which is 2, squared, times dy dt, which is negative 2, plus 2 times my x, which is 4, times dy dt, which is negative 2, plus 2 times my y, which is 2. We don't know dx dt. That's what we're solving for, equals 0. 2 squared is 4. 4 times 3 is 12. Times negative 2 is negative 24. Plus, negative 2 times positive 2 is negative 4. Times 16, times 4 is negative 16. Plus, 2 times 2 is 4. Dx dt equals 0. If I combine these two, I get negative 40 plus 4 dx dt equals 0. I'm simply going to add 40 to both sides. I mean, I could solve it at this point and know that that's going to be 10. But let's just finish the algebra out. We got 4 dx dt equals 40. And gosh darn it, don't you know I'm going to divide both sides by 4? And I get 10. That was a beautiful problem. And that was not that difficult of a related rates problem at all to do. I'm digging it. I'm digging it. I'm digging it.